Hello, everyone, and welcome to Creating a 3D GIS from Imagery and Lidar. This is part 3 of our Integrating Imagery webinar series, and we're excited about today's presentation because it's all about 3D GIS. This is an exciting new way to visualize and actually do analytics against an immersive form of information that allows you to truly understand your world. I'm excited to be joined by two amazing guys that I seriously enjoy working with. The first is Mark Romero. He's an imagery specialist here at Esri. The second is Ron Barrett, and we've worked with Ron for a long time. He's the managing director of Barone and Associates, and he's going to be showing some very amazing stuff that he's been able to set up with managing massive LiDAR data sets. My name's Kurt Schwope. I'm the imagery industry lead at Esri, and I'll be starting off today's presentation with a series of PowerPoints and discussions. This is the agenda that we are going to be working with today. You can see we're going to be covering a number of major things, all with regards to creating 3D GIS from remotely sensed sources. The one thing that we would like to point out is that anytime during the presentation, if you do have a question, just hit that little tab on the bottom of your webinar screen and type your question in there. And we'll have time at the end, and we'll answer as many questions as we can. And if for some reason we don't get to your question, we'll actually respond to them via email and share them with you. So eventually, hopefully, we'll get you the answer to the questions that you have. So before I begin, let's go ahead and switch over and take a polling question number 1. We always like to get an idea of, what the audience is familiar with, and that gives us an idea how we can talk. So Noel, if you can bring up the first polling question, that'd be wonderful. So, polling question number 1, please feel free to respond, is, does your organization currently have access to LiDAR and point cloud data? So the votes are coming in. Okay, very interesting. So 60% of you have some access to LiDAR data, and 22% of you have access to a lot. And then the remainder are just maybe perhaps starting to work with LiDAR point cloud data and want to figure out how to take advantage of it within their organization. Thank you for answering those questions, and we'll have a couple more as we go through the presentation. But that gives us an idea of who we're talking to. So, we always have to start with some of the obligatory sides up front, but these are very important because at Esri, it's all about the science of where and the ability to use that technology to connect up just about everything. And because we're involved in the remote sensing field, we in particular like to focus on some of these new and fancy modern sensors. And we're seeing how much information that these things can really provide about our built environments, the natural environments, all these different things. And so, our goal behind the software is to bring these all together, being able to access it and create this, information about everything connected up. We have a framework that does that. It's ArcGIS. And ArcGIS provides these 3 critical components. Number 1, it establishes a system of record. That system of record is your authoritative data that you can use then to drive a system of insights, to understand more about your data and how it applies to your organization. And then finally, we all know that this data doesn't do any good sitting on your computer, but you have to have some type of system of engagement and get that information out and share it with others. For imagery and LiDAR data, these capabilities overlay right on top of the platform. We have a powerful LiDAR and imagery management capability. You'll see that we have a number of new analytics associated with working with LiDAR data, and we have an exciting new way of delivering that content out to end users through our system of engagement. And this is just an example of how we can share and display data. This is actually an integrated mesh layer. It's generated from both point clouds and in the imagery, and we built some very nice scene models to go along with that. So this is just an example of being able to create a scene layer package that can be shared and observed directly now in ArcGIS Desktop Pro and our online tools. But it takes a platform to put that all together, and that's really the strength of what Esri has to offer. That's our comprehensive imagery and point cloud platform. And it seamlessly integrates those types of remotely sensed 3D sources with all other types of GIS layers. Where we like to focus in on our 4 key areas. Those are visualization, analysis, map production, and image management. Today, we're not going to talk too much about map production. That was actually done in our last webinar where we talked about our photogrammetric capabilities. But today, we will talk about the other 3, visualization, analytics, and of course, the management of these massive archives. Because as we know, for those of you who have worked with point clouds, they tend to be very large. So first, let's talk a little bit about the content and how we bring that into the system and what's available. What we provide is, because we are GIS users, we don't like to think in terms of files. We like to think in terms of areas of interest. So instead of working with an image, we work with a mosaic of images. Instead of working with a single LiDAR image, we want to be able to work with multiple LiDAR images to cover our area of interest. Those in turn feed in with a number of other layers to produce this 3D GIS. So a geoinformation model is actually very critical to the success of what we want to do. We have a very powerful geoinformation model that works around working with imagery to the point where we have complete photogrammetric capabilities now. Matter of fact, 3 different products are available to you in order to create a whole variety of different derived information from photogrammetry. One is the drone to map. I think probably many of you have heard about this before. This is a dedicated app that's focused on specifically taking imagery from drones and creating a wealth of 2D and 3D information products. The other 2 products work very closely together. The Ortho Maker is our ArcGIS Pro capability that does a block bundle adjustment of both aerial, drone, and satellite imagery. We have a similar capability that works now with servers so it can operate in the cloud, and that is Ortho Mapper. And all these 2 work together. Excuse me, I got those reversed, switch those around. Ortho Mapper is our cloud capability. Ortho Maker is our capability inside of Pro. But together, those 2 solutions can work with taking your raw imagery from different sources, doing block bundle adjustments, and creating a wealth of different information products. And this is an example of those photogrammetrically derived products. Obviously the base mapping is critical, from the orthos to the DSMs to the digital train models, all the way up to creating contours. But these tools are also very powerful in that they can create point clouds, photogrammetrically derived, 3D meshes. We can populate scene layer packages, and then we can also do these inspect and measure type capabilities where we actually interact and accurately measure what we're seeing in the 3D collection of photos that we're working with. One of the new capabilities that we have in Pro is around our stereo extraction tools, and all the editing tools that you're used to, creating an editing function or, building up feature layers using different edits and modifications of feature layers can now all be done in stereo. And this can either work in an anaglyph mode or with the stereo glasses. So you can do this precise 3D extraction of buildings, features, those types of things directly off the stereo imagery. So we're excited about that new capability. And then just an example, one of our customers, Will Shewart at Virginia Commonwealth University, he uses drone to map fairly extensively and does these massive collects, in this case 4,800 images. And you can see the type of photo-derived 3D products that he's able to get using the drone to map solution. And then, of course, visualizing that using our scene layer package capability. But enough about photogrammetric derived products. We talked about and presented that in our last webinar series, and you can actually watch that video if you didn't see it. But now let's more focus in on laser scanning type approach. And there's 3 different methods that really work on this. The aerial collection is kind of more the traditional LiDAR you're used to working with. And that evolved also into a terrestrial capability where surveyors would go out and actually put a laser scanning device on a tripod and collect certain areas. As those collection speeds got faster and more points could be collected a second, they were able to put the laser scanning on mobile devices. And now they're able to drive along roads or put it on railroad engines and drive around railroad right-of-ways and collect these massive 3D data sets that can be used. And so our challenge as a geospatial company is being able to access all that data and do something with it. And so that really gets into this whole management discussion of these point clouds. And so that's where I'd like to focus next as we go through the discussion. ArcGIS for a long time has had very powerful ways to work and support raster data. Right now, the image server has been proven to be able to work with petabytes of imagery and be able to serve that out via web services for both client-side and server-side processing. It works very powerful for imagery. The goal is, how do we get this working now for point clouds and those types of data? And so we implement the notion of a LiDAR data set, and we've started to work on optimizing this for kind of a services capability. And I'll talk about the evolution of how we were able to do that. But before we go there, I'd just like to point out a few key naming conventions. First thing that I definitely want to point out is that Pro now can natively read a LAS file. So you can simply drag and drop a LAS file right into your screen, and then you'll be able to bring it up, visualize it, do measurement, and do different types of analysis directly on the file. It used to be that you would have to have a LAS data set in order to be able to do that. That is no longer the case. But where the LAS data set comes in really powerful is when you have multiple different LAS files that you want to work with kind of seamlessly. And so the LAS data set is still critical to kind of create these virtual mosaics of point cloud files themselves. We also understand that some of these data sets get extremely large. People have limitations on how much storage they have. So we also implemented this open standard called ZLAS, which does provide some compression to push those file sizes down. It's not required, but it's available to you if you want to take advantage of it. So the LAS data set is very powerful. It allows you to do and work with multiple LAS files like it's a single file, but it still wasn't optimal for setting up some type of serving and delivery mechanism either to thick or thin clients over the web. And so we now started working on a new solution. It's been out for a couple years now around the scene layer package. And just to kind of show you the evolution of now how all these things came together. So in the first case, as we talked about, is that we get our LAS files and we'd actually generate a DSM or a DTM from those files. We put those into a mosaic data set. The image server would serve them out, typically as 2D products for some type of exploitation. And using the power of the image server and the mosaic data sets, we could actually apply raster functions to those derived data sets and create hill shades, painted relief, slope, aspect, contours, etc. And so this was our standard way of working with point clouds for a while. But we realized that people actually wanted to work with the 3D data. So we developed a way to take those LAS data sets, push the point cloud files up into the cloud or on top of server, but then also create a feature layer that consisted of the LAS footprints, and then set up a way to actually go in and using those LAS footprints, pull out those point cloud files and bring those point counts down locally so you could do analytics on your client. It wasn't optimal, but it did give you access to the 3D data instead of just the 2D derived data. But now this is the power of the scene layer packages and the I3S format, is that we can now push scene layer packages into Portal and make those accessible as 3D layers live either in a thick client like Pro or in a thin client such as what you get with ArcGIS Online. So we're very excited about what these scene layer packages now are going to offer us from being able to do 3D via services over the web. So let's talk about this scene layer package. And what you're actually seeing here is a massive point cloud of Sonoma County, California. And it was actually brought into Pro and then published into a scene layer package and pushed up into ArcGIS Online. And you can see that we can actually go in and work with this layer very effectively. This is millions and millions and millions of points, a few gigabytes of data, and we're able to work with it somewhat seamlessly and display it in a thin client in a web browser. And you'll see that it's smart enough to know how to thin it as it goes out, so it always kind of maintains this constant resolution as you look at the different data set. So it's just very powerful. And so essentially what a scene layer package is all about is our new I3S format, which is basically a container for storing large amounts of heterogeneous distributed 3D geographic information. It's not just point clouds. This is designed for any type data set that you might want to work with in 3D. We built it specifically for working with a web experience, and so it's mobile and cloud friendly, and it's built around common standards for the web. It supports both Cartesian and geospatial coordinate systems, so you can work, creating all different types of 3D geometries with your data. And it supports this notion of epsiloidal and orthometric vertical reference. That allows you to do very precise measurements in 3D and get those, geospatially very accurate. So, that's really critical for your authoritative data that you want to work with in a 3D type environment. And then probably the most important thing about I3S, one that we at Esri are really proud about, is that it is an open standard. We developed the I3S and we took it to the OGC community. We gave it to them and said, this is something that we think the community could benefit with, and we want to make it open and available to everyone. And so OGC liked it, they accepted it, and now anybody can develop 3D environments using the I3S solution. As I said before, it does provide a container for multiple different types of products, whether they be point clouds, 3D meshes, 3D objects, or even models that are positioned using a point layer, if you will. So, obviously the point clouds and the meshes are somewhat obvious. The 3D objects are any type of 3D model that you might have, you can display and render. And you can maintain all the attribute information associated with those objects. And the same goes with models. If you just have a point cloud and it has a attribute associated, maybe this one is a person or a light post or a tree, and you can actually have the system display the models associated with that attribute that's associated with that particular point on the ground. So that's really what the I3S scene layer is designed to do, is to present that in a web environment and be able to access your 3D data in a very visual setting. Now let's just briefly talk about analytics. I'm not going to say too much because Mark is actually going to go through a demo of this capability. But you can see here now that we've added the capabilities inside of Pro to do bare earth classification. We can classify buildings. We can classify objects based on their height. We can use different feature layers to help with the classification. And of course, we can change all the class codes so you can build up these tremendous referenced point cloud data sets for your GIS. There's a new LAS height metric, which essentially provides statistics for your point clouds, and it does things like mean, standard deviation, skewness, kurtosis. This is all basically for the forestry community, so they can set up these statistical metrics to go in and get densified point clouds covering forest areas and do all types of analytics to maybe predict harvest yields, forest health, those types of things. So that's a new GP tool. Another new GP tool is ThinLAS. And this is especially important for terrestrial-based mobile LiDAR systems. You can imagine that this actual image was taken off of a terrestrial LiDAR mounted on a locomotive, and the train came to a stop, and while it was sitting there, it collected over 40,000 points within 1 square meter. Well, that might be just a little bit redundant. So we now have a solution that allows you to go in to a LAS file and logically thin those data sets to get rid of all those redundant points. And then probably the one that we're most excited about, because we're imagery and LAS people, is the fact that we can now take our imagery with a point cloud and we can colorize that with the RGB values. So if you have a point cloud out there and you're working with it and you want to color it and make it look like a photo, you just run that GP tool and it'll assign the RGB values to those points and create this photorealistic point cloud. So, this is a great new capability to help with the visualization. A number of other enhancements are either out or on their way out, from working with the different class codes, better importation of OBJ file formats. We're really working on cleaning up the adjacent building footprints so we can do that 3D building extraction. So these are just all powerful tools that we're able to come with to do that extraction from imagery, or excuse me, from point clouds. And then finally, once again, the power of the visualization, we can put this all together inside a Pro now, and we can do things like, view sheds and terrain relief and come up with this solution of dropping observer points down a particular area. It'll interactively work with all this information. And you can see this is just a case where we put a couple observers on the hill, and we're actually dynamically figuring out what they can see and what they can't see in a 3D environment. So that's kind of some of the fun that we're doing, and I think it's really exciting with a wide capability of tools. But rather than listen to me talk about it, what we're going to do is we're going to do our second polling question, and then we're going to turn it over to Mark, and Mark is actually going to show you how this is done. So the polls are now open, and our second question is, if you do have access to LiDAR data, what are your primary uses? So people can fill that out. Boy, the currently do not use LiDAR data guys jumped ahead initially, but now they're okay. It looks like this is good. This is somewhat as I expected. A lot of elevation models and contours. That was clearly the lead, followed by visualization and 3D extraction. So it doesn't look like we have too many foresters or agricultural people, 12%. But anyway, I appreciate the feedback on where we're going. So now I'm going to turn this over to Mark, and he's going to give a demonstration on this feature extraction. So Mark, I've made you the presenter, and so it's all yours.
All right, thanks, Kurt. Give me a second to push the button here. And can you see my screen?
I can. Looks good.
All right, thanks. So following that last survey question, I'm just going to jump into some of the different derivatives that many of our users can create from LiDAR point clouds. And so you can see these here in ArcGIS Pro. And this is a set of points from a county in Virginia. This is Fauquier County, and there's other data sets that are better looking, but I chose this one to demo the capabilities because this is actually data that I got downloaded from the 3DEP USGS website, and so this is a common way for our users to access data, and so I thought I would use this as an unpolished data set to show how you can actually generate some of these derivatives. And so you're looking at them right now. So on the top left map here, you're seeing an actual classified point cloud that I used using the tools in Esri to generate these. And so if I toggle, turn off the building footprint, you can see that I've classified the buildings in red, some ground points in brown, and then some vegetation in green there. And I'll walk through the capabilities of how to do this. But one of the common features that you can extract from here are the building footprints, an example. And you can see that highlighted in yellow. On the bottom left, and some of the folks pointed this out in the poll, another derivative that is commonly generated from point clouds is elevation data. And so this one that you're looking at here is the DSM, basically showing the terrain, everything above ground in addition to the ground. And so that's another example. And then finally, once you generate these two on the left, you can start to extract out other kinds of valuable information. And so the 3D image on the right is showing some of the 3D building footprints, as well as some of the vegetation that can be extracted. And this is displayed in sort of a thematic view or representation of the data. But as you start to look closer at these building footprints, we're actually generating more than just the footprint. We're generating the pitch of the roof and trying as best we can to model the 3D buildings in this case. And so the accuracy and the resolution of these 3D building models depends on the point spacing and the resolution of the point cloud itself. So, so just a few examples of some of the derivatives here. And so now what I want to do is actually go through the steps of how to start managing the data and start working with the LiDAR points themselves. So I'll turn off a few layers, close a few maps here. The first thing that I want to point out simply is that, and Kurt mentioned this, is that we can start now directly working with the raw LAS files themselves. And so this is just one scene or one file that I'm displaying here. You can see the .las extension. So in addition to that, that's great for working with single scenes or single LAS files. But we can also create a large collection and work with large collections of LiDAR data sets or LAS files. So in this example, I'm not displaying the points, but I'm displaying the footprint or the boundary, the outer boundary of, in this case, I got probably 16 different LAS files all into one collection. And so this is a great LAS data set, great tool for those of you that are gonna work with large collections of this data. And so based on the poll, I think a quarter of you sounds like work with large collections of data. Okay, so how do we start working with this, or how do we even create these things? So I'll go ahead and open up my catalog window and run a geoprocessing tool to actually create one of these LAS data sets. And I'm just moving my go-to window aside. So it's very simple. We can pick any folder or any location to store the LAS data set. So I'll just pick one here and then simply right-click the folder, hit New, and then hit LAS data set there. I can give it any name. And that's an empty container at the moment. And then once that's generated, I can start adding individual files on there. And my system's waking up, so there we go. All right, so we've got an empty LAS data set, and now I can start adding data to that, and I can do that by navigating to all the files on disk. And so I can go directly to the LAS files. I'll just pick 4 here for the sake of the demo, and then add those in. So you can see the tool is now adding those 4 individual LAS files to the LAS data set. And I can actually generate statistics about those points. So here the system's telling me the total number of points that I have, if any of them are classified. So in this case, I've got no classified points, are all pretty raw, and the range of the values, and just some other things that you might want to know about the information. So a lot of valuable information that is generated within the LAS data set itself from all these different points. And that's really it. And once you do that, you can just drag and drop that right into the system. So now we can start working with it. So I'm gonna go ahead and zoom to an area, and I'm gonna turn off the one that I've already processed that looks good, and then turn on the one that is pretty raw here. So here's, again, a point cloud. And this is typically what happens when you load a raw LAS file or LAS data set into Pro. It's just a bunch of unclassified or raw points that you're seeing here. And so there's a couple different ways to work with the data. And in Pro, we've provided a nice ribbon interface that makes accessing the symbology tools readily available. So if I want to, I can actually change the points to display them as elevation values. And so now I can see that range of elevation values. And I can change these in all kinds of different ways. Okay, so because it's raw, I can't really do that much with it. But I'm going to change it back to classification and just view the points. So the first thing that I want to do is actually do a little QA, QC on this. So I'm going to go to the geoprocessing tools. Often when you get LAS files, there's going to be a bit of QA, QC steps that are involved to start extracting information from there. And so one of the tools that you would commonly run is this one here. This is classify overlap. And so I can go ahead and hit run. And what that's going to do is find all the points that overlap from the different flight lines. And so the reason that we would want to do this is because if we're using this product to generate elevation surfaces, we want to remove points that may have more overlap over one part of the scene versus some that may not. And so you can see just by running that tool, I've now kind of smoothed out the lines. And now I can go in and actually filter and turn on the overlap points. And those are all displayed in purple here. So what the tool's done is essentially identified or classified those as overlapping points. And so now I can go in and just check that off. And now I'm displaying only the points that that are sort of consistent and smoother across the scene. And so once I've done that, I can start classifying the ground. So you saw here I reached into the geoprocessing tools. Another way to access the classification tools is directly from the ribbon. And there's a dedicated classification ribbon, and on there are some tools you can drop down and easily access these. So next I can classify the ground, and I'll just use the standard default resolution here and run that. And so this is generally going to be an iterative process. You're not always going to get the points to classify perfectly the first time, and so that's why there's different types of methodologies to be able to do that. And so so now I've got my points that are displayed in brown, and those are representing the ground points. And I can keep on going. I'll do one more. I'll go ahead and classify the buildings, and I'll go ahead and hit that. I'll probably change the parameters. And so you can see as I start running through these tools, I'm starting to generate more classified points that are going to become useful when I start to extract out these features. And so last one is classified by height, and this is generally used to classify vegetation points. And as you notice here on the contents panel, you'll see the numbers that represent the different classes. And this is just using the ASPRS standard way of classifying LiDAR points. So just so you know exactly what these mean. And then often a lot of our customers actually have existing feature classes. So for example, many of our customers already have building footprints that they may have generated. You can actually use an existing feature class as well to generate, to classify the points themselves. So what I'm doing here is ingesting in a building footprint layer that was done by an aerial provider, in this case Sanborn, and then I'm using that as an input into classifying the points. So now when I hit that run button, and this one takes a little bit longer because it's looking at the extent of each feature class, and then it's going in and classifying those points based on the extent of that feature class. So this is useful for building footprints. If you already have those, it's also useful for the extent of a roadway is another good use. And there's also a lot of other use cases for this particular tool. So we'll let that run, and looks like we're done. And so now as we really zoom in there, you can see a nice classified building footprint there in red over the aerial photography. Okay, and so really that's kind of in a nutshell some of the classification tools. As I said, it's not always going to be perfect the first time, and oftentimes as a power user you may have to actually go in and manually edit and pick some of these points. And that's all built, again, right into the interface. You can simply select the building or the points that you want to classify. So here I just selected a collection, and then using this drop down, I can pick what that feature might be. So I know that's a ground point. I'll just hit apply. And so that's how we can manually classify some of these. Okay, so once we've done that, what next? And so now we can start to begin the process of actually performing feature extraction against the data set. So all of these workflows are very well documented. All the tools are provided to be able to do feature extraction. And so what I'm going to do is just show an example of how you can extract building footprints if you're a customer, for example, that doesn't have access to pre-existing building footprints from an aerial provider. All the tools are freely downloadable. Some of these are actually out of the box, but they're very intuitive, and they're sort of you do one step at a time, and the tools are actually labeled 1 through 5, 1 through 6 here, and you just simply click on one tool. When you got the output, click on the next tool, and so on until you get to the end of the steps. And so over that same area of interest, I've essentially gone through that, classified the points, then generated the raster footprint layer. You can see it kind of looks somewhat irregular. And then as you go through the steps, you start to generate all the necessary outputs that are going to allow you to have a nice output at the end of the results. So this last tool here is kind of we call this the generalized footprint tool. This is out of the box. If I turn off the point cloud, you can start to see the building outline closely represents the actual building footprint itself. And it's not just rectilinear type features. It'll also generate those features over round buildings or some that are not quite regular. Okay, so what I've shown you is kind of like a step through workflow of generating these building footprints. Many of our users don't or get data that's unclassified, and so we actually have a very similar workflow for running through and generating building footprints from unclassified LiDAR. And same type of thing, it's a set of tools 1 through 6 that you run through to generate these types of surfaces. And so we can get something very similar. Here's kind of the rough raster layer representing the building footprints. And then of course, once we run it through some of the tools, we can get a much better representation. And so what I want to do is actually show a web application that shows the result of running through the classified workflow, the unclassified workflow, and then compare that to one that's been generated from a heads-up digitizing process from an aerial provider. So the panel on the far left, this is using the tools for the classified workflow. You can see that it's not perfect in some areas, but it's really pretty good for most of the buildings in this particular subdivision. This panel in the middle is showing a comparison of that same area using the tools against unclassified data. And then finally, that one on the right here, in this case from an aerial provider. So there's an example of some tools that are available to you within Pro to be able to generate your own building footprints. And then, of course, once we do that, Esri's provided a set of templates. This is from our solutions page. And this is a way to take those building footprints and actually push them up to ArcGIS Online to make them more usable and yeah, basically to make them look better if you need to share these. And so I wanted to show you some of the results of that. And so here is the same, the end result of the data set from Virginia and Fauquier County. And so what I've done is just zoomed in a little bit to show you the end result. So you can see we can actually generate the pitches and get a more accurate representation of the building. And again, this is going to vary depending on the point spacing and the resolution of the data. You'll see that we're streaming this over the web. And what you may not know is that what's making this happen is the I3S index format that Kurt talked about in this slide. And so again, this is our way of being able to display 3D content, really no matter what it is. It could be a point cloud, it could be a building footprint, It could even be a textured mesh. But i3s makes it possible to generate and display this 3D content and stream it over the web, and you can see the performance is really good. And this is millions and millions of points that we're displaying right here in a web browser. Thin client, no software required, no plugins. A good way to be able to display and share your data. So I'm going to go ahead and turn it back over to Kurt. Thanks.
Great. Hey, Mark, that was outstanding. That was really great. Exciting to see that Fauquier data set and do that type of extraction. So before I switch it over to Ron, Noel, if you could bring up the third and final polling question. The question is, what are your difficulties working with LiDAR data? Go ahead and select which one best fits the type of work that you do. And in the meanwhile, I'm going to switch it over to Ron, who's going to talk about a solution that he's helped put together with one of our partners, Regal Systems. And it's called LMAP, and it's designed to start managing and working with massive volumes of point clouds. So the polling results are coming in. And very good. It looks like the biggest problem is extracting features. So hopefully Mark's presentation helped somewhat, and we're standing by if you need further help. Mark and I are always available to help you do that. And then the second biggest one is working with those extremely large data files, and Ron is going to help us out with that. So Ron, I think I've given you control, and so now you just have to unmute yourself and start your screen and kick off what you have to present.
All right, Kurt, thank you very much. Kurt, can you hear me?
We can hear you.
Okay, and can you see my screen?
I can see your screen too.
All right. Well, first of all, I want to thank Esri for the opportunity to kind of share some of the work that we've been doing. The one thing that's kind of been interesting in the time I've spent working with LiDAR data, it's been about 13 years now, is that first of all, it's getting easier as far as to actually do the collections. Second of all, the cost is coming down, and in many cases dramatically. But what I'm most excited about is actually that it's gotten so much better as far as the quality goes. And so what you can do with it is really nothing short of amazing. What I'm going to do today is I'm going to talk about something that we've been working on with Esri. And when I say we, I'm referring to Regal Measurement Systems. Regal, just brief background, is a company based out of Austria, and they make everything LiDAR. They make airborne, both manned and unmanned. They make LiDAR that you can put on tripods, and they make mobile LiDAR, as Kurt was talking about, that you can put on vehicles, whether it be automotive, trains, things of that nature. We've been having, Regal and Esri have had a partnership for a number of years now, and about 2 years ago, working with Kurt, we kicked off this new idea called the LMAP initiative. And the idea was, okay, great, if you can collect lots of LiDAR, now what? And so we decided we'd come up with this this concept to try to engage with some of Esri's newest 3D technologies. And what we want to do is be able to manage and then analyze and visualize LiDAR data. Because, if you can collect great LiDAR data, but you can't get your hands on it, and it's sitting in on hard disk drives in a cardboard box under somebody's desk, it's not nearly as valuable. So we came up with this idea of trying to do it in a way that it would be much more user-friendly, and also leveraging things like the web, like the cloud, and in a way that's scalable. So when you're doing a LiDAR collection project, and I don't know how many of you in the audience actually are involved in the collection part or the processing part, but there's a lot of bits and pieces that go along with it. And some of them can be very important downstream. And so the idea of being able to keep all this information together can be really, really important as far as, again, maximizing the value that you can get out of the data. And it starts with things like where's the LiDAR data stored? And so what we've been looking at is an entire workflow. So Regal has their workflow that takes what comes off of the airplane or the terrestrial scanner and runs it through a process. Basically, the end result of that you can think of as the .las file, an unclassified LAS file. And that's the starting point and kind of the handoff today into the Esri platform. But then we go through things and we create some of these derivative products, or we publish it in ways that then get pushed out into ArcGIS Online or possibly Server. So what I'm going to do now is I'm going to jump into a web demo. I'm going to want to do my standard disclaimer, which is this is all pretty much live, which means anything can happen, and we are going to be using massive amounts of LiDAR data. But just to overview what you're going to see here is this is a prototype that we've built at Regal to basically demonstrate these concepts of LMAP. And what we have now is 11 projects that were collected on 3 different continents in every type of LiDAR instrument that you can imagine. So throughout the next few minutes, I'll show you data from terrestrial, from airborne, manned, unmanned. I've got some really nice data from the Netherlands that was collected on rail, and also some potentially, if we have time, I'll show you some data that was collected mobile on highways in Florida. So just to give you a little bit of a brief overview of what the LMAP initiative or system looks like, is there's really 2 pieces to it. The first is kind of the heavy lifting, non-sexy part, which is done in ArcGIS Pro. And what Regal has done is taken in the .las files and create what Pro calls tasks and model builder models to start to automate that ability to create these other products that really start adding value to your LiDAR data. So I'm not going to touch at all on the classification and things of that nature. I think Mark did a great job on that. I'm going to talk about more what happens after that. So we've got all these last files now, and we're going to, and all sorts of metadata, could be QC reports, could be all sorts of things, and including imagery. And we're going to start making things out of those. So for example, what we want to be able to do is create tile boundaries. We want to do project boundaries, possibly create some 2D derivative products like your digital surface model, potentially hillshade, the digital terrain model. We're also very keen on this I3S seam layer package or web seam format. So we're going to automatically create that file format again in Pro, and then we're going to take that all and publish it into either ArcGIS Online or Server. So let me start and show you a data set, and this is in Austria, and this is the headquarters of Regal. They've flown it a number of times over the years, and what we've done is we've taken the DSM and we've used that in the web map for our presentation. And I know there's a bit of latency here, so I'll try not to get too far ahead of the display. But what you'll see is the quality of the data and the presentation is, in and of itself, is pretty good. And as I zoom in, you'll see it just gets better and better. What we're seeing here is the high altitude large LiDAR scanner, the Regal 1560. And you know, we can look at a variety of different things that we've done with this data. Again, this is basically to organize and manage your data. So we've got things like scan boundaries. We can look at where the different data sets are. And again, there's 3 data sets overlaid on top of each other here. One from 2012, one from 2015, and one from 2017. And I'm not going to go through and give you a demo on exactly how you can search and sort for this. I think that's for GIS folks, that's pretty fundamental. But because we've read in all the metadata, if you do want to look for things like show me all the scans that were done of a region, show me all the scans that were done at a certain time, show me all the scans that were done with a certain instrument, of course you can do that, and it's quite straightforward. We also can look at projects, and we can also look at tile boundaries. And again, we've got all sorts of things. Going back to the projects, we can click on that. We're using the pop-ups, and again, you see it says 1 of 3, and this tells me now for this Horn 2012 what the instrument was and some information. I can actually look at the QC report for that particular collection. I've been able to tag along this PDF file and make that readily accessible if you care about that. And we can look at the other 2 data sets as well. If we want, we can also look at things at a tile level boundary. Same things, we're using the pop-ups. And here we've got the horn data set. But what I've now done is I've wired it up so that I can acquire that image. So when I hit view image, what it does is it asks me where I'd like to download that DSM onto my desktop. In this case, we have just the DSM wired up, but if you wanted to, you could also do the .las file. So let's say that you've got a data set and you want to do some work and you need 5 of the tiles to work with. Instead of trying to find a hard drive, plug it in, try to search for in file folders, now you can do it by location. You can sort by date or scanner, and then just that simply download it to your desktop. So we're trying to take advantage of a number of these capabilities that we've dialed in with the Esri technology. Let me turn those off. And I have got there we go. We're also using things like bookmarks. We can jump to different locations. And here is an area, but we've also deployed some of Esri's tools. And in this case, we're using swipe. So now we're looking at just one DSM compared to another DSM. And maybe for some users, they just care a little bit about some change detection in a certain area. Just that quickly you can bring up, and I don't know how that's showing over the web, but you can see there's differences between these two DSMs. And we also have things like tools so you can do measurements. I'm going to now jump to another data set that we've got some pretty interesting data on, and this is a monastery or a castle, again, also in Austria. And this has been flown both with high altitude LiDAR. It's been flown with a UAV LiDAR data, and it's also been scanned on the ground with terrestrial. With the high altitude, we've created a DSM. So you've got your bare earth here. Again, the data, as we zoom in, gets better and better in 2 dimensions. We can look at it as a DSM. And we can also look at the drone data. And again, you'll see the level of detail is quite high, particularly as we get into the drone data. And this is all pretty interesting, but there's other information that we might want to look at, or if we want, we can turn on projects again, jump into the pop-up, zoom out so you can see that a little bit better. I've got 3 different data sets. This is the terrestrial one. That's the high altitude Q1560. This is the Rycopter one that I'm particularly interested in. And we've wired up, in this case, the theme layer package. So all those will take a few seconds over the internet. I think very quickly you get the idea that this data was collected at very high density, and it also utilized a camera. So we've got a colorized point cloud here. And now, using no desktop software, we've got the theme layer package. And we can start to zoom in. And again, there's always a bit of latency, but I think you'll get the idea pretty quickly of what the quality of this data is and the kind of things you can see and do in it. One of the things that I'm most excited about with some of Esri's newer technology is the fact that now we're not only able to look and view things in 3D, but we can actually start to do some other things. And although it's a simple thing, one of my favorite things is to be able to do measurements. So I think in a lot of cases, for casual users, if you can see things in 3D and you can make just a simple measurement, it's pretty powerful. So what I'm going to do here is, if I can, is I'm going to measure the height of this little, whoops. Try that again. So we can very quickly measure both linear and area measurements in 3D now in a scene layer package or a web scene in a browser or an iPad. So let me put that away and jump to one additional data set I wanted to show you. And as Kurt mentioned, they're starting to put LiDAR scanners on trains. There's a lot of assets, a lot of infrastructure to running trains. Again, here we're looking at it in 2 dimensions as a hillshade, but that's not nearly as interesting as looking at it in 3 dimensions in a scene layer package. So again, with relative ease, you can wire this all together, open up a new web browser, and then loads the scene layer package. Here we've got it visualized by elevation. And I can't remember if it was Kurt or Mark that mentioned that, you know, you can colorize these point clouds and show it by color like we did with the castle. You can do it by height, and also you can do it by things like intensity. So you give that a moment or two to stream in. But you'll see there's an awful lot of information that's been captured. And the thing that is also important to keep in mind is that with these Regal scanners, not only are you getting incredible detail, but you're also getting incredible accuracy. This data is now being measured in millimeters, not centimeters, but millimeters. And so for somebody who's running a very complex infrastructure like this is an excellent way to manage or to collect data, but you also need to manage it. The last thing I want to show you is the fact that we can put this in a dashboard. So here is the 11 data sets that I was referring to. We can look at and jump to any one of them. With this particular one, we've got different levels of QC processing. We can look at the tiles and look at which one goes with which. But we can also look at the level of QC that's been done on those LiDAR data sets or any other attributes that you're carrying along. So by just clicking on the pie chart, I can look at and visualize the different pieces of information. So the dashboard is a powerful way to not only capture your data sets and figure out what's going on with them and where they are, but to be able to actually do some higher level interrogation, which I think from a management perspective can be quite useful. So as you and your organizations get more and more and more and more and more LiDAR data sets, this is becoming, I think, much more valuable and useful. So with that, let me wind up and turn that back over to you, Kurt.
Excellent. Thanks, Ron. So I take it on that last point, it's actually setting up a production management system where you can actually set up a QA process. So if somebody's out collecting, they can just publish and off it goes, and they can do QA reports through the dashboard. I guess that's just amazing stuff, and be able to visualize everything in 3D. So appreciate you being able to show that. Ron talks about latency. I'll give you the real reason why Ron has latency is because he's sitting up there in his chalet in the mountains of Montana giving these presentations. So anyway, it came off really good, Ron, and we appreciate you showing it. So as we've gone through the webinar itself, Mark and I have been kind of typing very quickly into some of the questions that you've asked, and I think we've answered most of them. Let me go ahead and pop out the question dashboard just so I can kind of see it a little bit better, see if there's any easy ones that we've missed. Okay, just scrolling down the list. I made a mistake. I actually typed an answer to the question with regards to the difference between um, the ZLAS format and the LAS format, and I put that in another category. So if you look, you'll be able to find the answer to that one there. And so, but to answer Diego's question, and maybe Mark, you can answer this a little bit better. Diego's working with a very large LAS file. If he's able to put that into a LAS data set, do you think he'll get better results as far as being able to work with improving the speed?
Yeah, one of the I might have answered Diego's question, but one suggestion I have is there's a GP tool called Tile LAS, and it'll take all of your LAS files and it'll sort of chop them up into smaller, more manageable sized files, and you can define the extent of the squares, so you can make them as big or small as you want. And so that's a good tool to run if you have really large single LAS file and they're taking longer to load into the software. And then once you have run the tile tool, then it's recommended to put them in a LAS data set, and then you'll get even better performance because the system's not trying to read out one single file. It's basically writing out the points that are within your display. So that's one step, one tool.
Awesome. And then Greg quickly asks, can we colorize the LAS data set from an image service, specifically the NAPE service, but I guess from any image service? That's my first time to really see that GP tool. Have you played around with that GP tool yet, Mark, to see if you can?
I believe there's no limitation on the raster. Any supported raster should work as an input. If it is the NAPE service, there's a tool called Make Image Service Layer. Make Image Service Layer. And what that does is creates basically like an in-memory clipped out image of you tell it what area you want to define, and you can even like control certain bands. So from NAPE, if you want just a 3-band scene over a smaller area of interest, you could use that tool and it'll make that, and then you use that output as the input into the colorized LAS tool. So that's one way around that.
Excellent. Yeah. So yeah. Anyway, Greg's going to try it. So we'll see if it works. Greg, let us know if you have any issues. We'll be happy to help you out. There is a question with regards to, are these tools for processed LiDAR data? I think probably the best way to answer that is the tools are for LAS files. So if you're working with native raw, returns from a sensor that haven't been processed into a LAS, they're not going to work. They're specifically designed to work with LAS files. And, there's different levels of processing that goes around into those LAS files. As you notice, though, one of the things that we've recently added is the ability to add classification to the LAS file data set itself. So that's where it starts. And we have automatic and both manual ways to go ahead and start adding that classification if it's not already part of your collection. So other questions? Yeah, we have recorded this session. Actually, if you look at my screen right now, we have this entire imagery and remote sensing community on our GeoNet page. So this is a great way to go in and interact with different people, answer questions. If you have any, cool story maps that you'd like to share, please, by all means, do that. We're just trying to build up a community around both imagery, remote sensing, and 3D, and working with LiDAR and those types of things. So, please feel free to participate in the whole GeoNet community. And just as a reminder, we actually have 2 more webinars coming up, one here shortly in November. And this is, we're going to get heavily involved into feature extraction using raster analytics and some of our imagery segmentation tools. And then in December, we decided to wait till the end of the year. We're going to be unveiling some of the latest efforts that we've done around AI and using different AI technologies to do extraction from features. So unfortunately, we're out of time, but for the questions that we didn't get to, Mark, myself, and Ron will sit down, we'll work through them, we'll get them posted and get them shared out to you. And once again, thank you for spending an hour with us this afternoon. And we look forward to helping you any way we can to get you up and being successful with this type of data. So thank you all very much.